and then they write plus 6x plus 12. So this is a mistake. So I don't want you to do this mistake. Students are taking the value of b, you find something like this. Like this. So this is a mistake and I don't want you to do that. Good day. Welcome back to our YouTube channel. If you're new here, welcome. My name is Tifla. I hope you enjoyed this, and also I hope you subscribe to our YouTube channel. So today we are doing completing the squares, and you're going to understand the importance of completing the squares, and also what do you solve with completing the squares. So let's just get straight to it and enjoy this together. So completing the squares is one of the oldest methods of solving general quadratic equations. Is that it is so much important and it is so much efficient in solving the equations. So quadratic equation, basic quadratic equation is given by ax squared plus bx plus c, right? So this is an expression. You know the difference between expression and equation. So an expression doesn't have equal sign, but an equation does have an equal sign. So now we are going to be dealing with expressions first and then equations, so that you will see how to solve the equations. So this completing the squares changes this equation or this expression into this expression, a squared plus q, right? So that's the importance of this. It changes this expression into that. So with this expression now, we can see that this is the x value of the turning point, and this is the y value of the turning point. So obviously a quadratic equation or quadratic function, it has the turning point where it turns, right? So already we can see that this gives us the turning points of an equation, right? So this is the turning point. So now it will depend on the value of a. Looking at this expression, if our value of a is greater than 0, it means that our function is concave up like that. So it will have a minimum point. It will have a minimum y value. So the minimum y value of this, you can just take it from there. So you can see already that this has already given us the turning point and also the minimum point of a function. And if your a value is less than 0, if this is negative, then you are going to have a maximum point, since it will be concave down like that. So it means that you are going to have a maximum point if your a is less than 0, and still this will be your maximum point. So this gives us the maximum point and also the minimum point. So this is the maximum and this is the minimum. So this is the importance of this. Apart from this, also the completing the squares. So these are the things that the completing the squares does give us. So it changes the basic quadratic, changes the basic quadratic equation or expression into the what? Into the turning point form. So this changes the basic quadratic equation or the standard quadratic equation into the turning point form. So this is the turning point form. So it changes a x squared plus bx plus c into a x minus p squared plus q. So also this gives us the minimum or maximum point. So every time they can ask you what is the maximum value or what is the minimum value of this expression, it means that we complete the squares, and this value, it will be our minimum or our maximum value depending on the value of a. If our value of a is greater than 0, then we are going to have a minimum point. if our value of a is less than 0, we're going to have a maximum value, just like that. And also completing the squares helps us in solving equations when we can't factorize. So if we are unable to factorize, we can use the completing the squares to solve for our values of x, or to solve the roots of an equation, of a quadratic equation. It also helps us to solve the roots of an equation. So this 1, 2, and 3, these are the most important aspects of this completing the squares. And apart from this also helps us in developing, so this helps developing the quadratic formula. So it helps in developing the quadratic formula. You remember the quadratic formula where x is equals to minus b plus minus square root of b squared minus 4ac all over 2a. So we can see that these 4 things we can get helped by the completing the squares. So now the question is, how do we complete the squares? So let's get to the how part now. So let's see the simple steps that can help us to complete the squares. So step 1, make sure that your equation or your expression is in the form ax squared plus bx plus c. That's the first step. And the step 2, check the value of a. If it is not 1, then factor out a. Step 3, after a is 1, take the value of b and multiply by half and square the results, just like that. Step 4, add and subtract the value of b multiplied by half squared to avoid changing the expression. So know that in the expression, in order to not change anything in the expression, what you add you must also subtract, what you multiply you must also divide, something like that, right? To keep the expression with the same value or the same results. And then step 5, replace x squared plus bx plus the thing that you have added by just taking this x and this value and square them, right? After that, we remultiply by a. So let's work with this step by step to show how we can do that. So step 1, they said we must make sure your expression is in the form of ax squared plus bx plus c, and this is in that form where our a is a. The second step, they said check the value of a. If it is not 1, so this is 1 fortunately, so it means that we are okay, there's no need to factor out. Step 3, after a is 1, take the value of b. So what is our value of b? Our value of b is plus 10. So we're taking the value of b and we are multiplying it by half and we are squaring the results like that. That's step 3. So what do we have here? This will become 10 multiplied by half, it is 5. So 5 squared, that's our results. And then step 4, add and subtract this to avoid changing the expression. So let's add it and subtract it. So we're going to have x squared plus 10x plus this 5 squared and then minus this 5 squared plus 25. So let's just write it here. So now we're having this expression like this. We just added this and subtracted it as if we didn't change anything. So the fifth step, they said replace x squared plus bx plus this what we have just found by this. So it means that we are replacing this, this and that which we have added, right? By just taking the first, the x there, and we are taking this which is plus 5 and we square that. So that's how we can replace this 3, right? So the next thing, let's just work out this. So this is minus 25 and then plus 25. So it means that this now becomes x plus 5 squared. So we have completed the squares of this equation. But also sometimes we may find the equation that is not having 1 here as the value of a. So let's find some of that equation. So it means that looking at this equation now, our minimum point is 0. Can you see that? Our minimum point is 0. Since the value of a is positive, we know that it will have the minimum point. So the minimum point is 0. So let's get to do another one, right? So let's take a look at this and let's see how we can work around these steps to complete that. So first step, make sure your expression is in the form ax squared plus bx plus c. So let's change this into ax squared plus bx plus c. So this is the value of a, so that will be negative 2 x squared plus, so this is the value of b, which is 6x plus 12. So now we are done with the first step. This is in the form of ax squared plus bx plus c. The next step is to check the value of a. If it is not 1, then factor out. So here it is not 1, so let's factor out negative 2. So factoring out negative 2, this will leave us with something like x squared minus, so 6 divided by 2 is a 3x, and 12 divided by negative 2, that's a negative 6. So we are done with this step. So step 3, after a is 1, take the value of b and multiply by half and square the result. So now our value of b is negative 3. So we are going to take negative 3 multiplied by half and then we square the result. So this will give us negative 3 over 2 squared, right? And then we can bring it here. We said after this, now we have to add and subtract this, right, which we have just solved there. So this becomes negative 2 x squared minus 3x, and then we add plus negative 3 over 2 squared, and then we subtract it at the same time, negative 3 over 2 squared, and then we are remaining with negative 6 there, like that. So we are done with step 4. Step 5, replace x squared, bx, and this thing that we have added by just replacing it with this first and this one over 2, and then you square that. So this, after multiplying out, we get back to this stage, and this stage factorizes to this stage, right? So now we can deal with this now. So this will be, this one squared, it will give us 9 over 4, like that, and then minus 6 there. So the next stage, we might wanna just add these ones, these two, right? So this is negative 2 x minus 3 over 2 squared, and after punching this in the calculator, we get negative 33 over 4, and then we close like that. So we're done with step 5. And step 6, we re-multiply by the value of a. So we are re-multiplying this by the value of a. So a is negative 2, it will multiply out. So this multiplied by that, it will be negative 2x minus 3 over 2 squared. And this multiplied by that, that will be a positive 33 over 2 now. Just like that, we've completed the squares of these. So since the value of a is negative, it means that we're having a concave down curve. So it means that now we are going to have the maximum value. So this is our maximum value of our expression. So if they say find the maximum value of this expression, you complete the squares, and this will be your maximum value of this expression. So if you follow these simple steps, no matter what you're trying to solve, no matter the complexity of your quadratic expression, you are still going to get it if you just follow these steps carefully, right? Yes. So before we get to other uses of completing the squares, let me just help with sharing the mistakes, the most common mistakes students make when completing the squares. So these are the mistakes. So since we know that we have to check the value of a if it is not 1 and factor out, right? So when factoring out, most students tend to do this. So if you are factoring out, they tend to do this. And then they write plus 6x plus 12. So this is a mistake. So I don't want you to do this mistake. So remember, when you are factoring out, also on this value, also in that value, you have to do the same. So the most correct way here, it is to do what? It is to say negative 2, and you're going to have x squared minus 3x. So this will factor out there as well, and also this will factor out there as well, like that. So that's one of the mistakes students make, like that, right? And the other mistake students make, it is this mistake. So now we have dealt with this first part of this. Now we have to take the value of b. Sometimes when students are taking the value of b, you find something like this. Like this. So this is a mistake, and I don't want you to do that, because the value of b, it is not 3, but rather it is negative 3. So you have to take with the sign by half, and then you square that. So this is the correct way that you have to do that. So avoid not factoring out completely, and also avoid taking this value of b without its sign. So always remember to take out the sign when you are factoring out, like that. So sometimes the other mistake that I left out is sometimes they just go on and complete the squares without first dealing with the value of a. So you cannot complete the squares with this without checking the value of a if it is 1, because you always have to complete the squares if the value of a is 1 there, right? So don't make out that mistake of not factoring out. So that's one of the mistakes, not factoring out, right? And the other mistake is that students often confuse expressions and equations. So just remember that an equation is the one that is having an equal sign, and the expression doesn't have. You find students solving for this equation, while you just have to solve for the expression. You find this now having something like this. Something like that, which you are not given at first. So don't make the mistake of doing an equal sign there. Just complete the square and finish it with these steps that I've shown you if you are completing the squares, right? So now, since I've talked about these mistakes, now let's go to the other uses of completing the squares, which the other uses are solving the equation now. Solving equation. So let's get to solving the equation now. So now let's solve for x by completing the squares. So we know that we can factorize this, but now we want to complete the squares, for in case when you don't know the factors, and also when you cannot factorize. So it means that this, we can start by checking the value of a, it is 1. So this becomes our x squared. Now we take the value of b. So the value of b is negative 2, and then we multiply it by half, and then we square that, which you get negative 1 squared. So this becomes x squared minus 2x, and we add that, and also we subtract that, right? So now we are going to add negative 1 squared, and we are also going to subtract that negative 1 squared minus 8 being equals to 0. And I said we can replace this by just taking this value and that value and square them. So this becomes x minus 1 squared, and this will be minus 1 minus 8 is equals to 0. So this is x minus 1 squared minus 9 is equals to 0. But now since we are solving for the equation, rather than just completing the squares, it means that now we can take this 9 to that other side. So our x minus 1 squared becomes 9. So now if it is 9, it means that we have to do what? To do the square root both sides, so that this and that will cancel out. So now we have our x minus 1 will be equals to, and the square root of a number is a plus or a minus. So this will be plus or minus 3. So now it means that our solution will become x minus 1 will be equals to negative 3, or x minus 1 is equals to positive 3. So here our x will be equals to minus 3 plus 1, giving us minus 2. Our x becomes our 3 plus 1, giving us 4. So this is how you can solve your equation, by completing the squares, just like that. Maybe let's find another equation that is not having the value of a as 1. Let's see how we can solve for this equation now. The value of a is not 1. So again, we check this first step. It is in the form of ax squared plus bx plus c. The second step is now to check the value of a. If it is not 1, then we factor out the value of a, right? But now in this case, since it is an equation, whatever you do on the left hand side, you can do on the right hand side, right? So now if you are solving the equation, rather than just factoring out, you can divide throughout by the value of a. So now we are going to divide throughout by the value of a, which is negative 3. Negative 3. So this will give us x squared minus 7x plus 6 is equals to 0. So now we are solving, we don't factor out, we just divide, because now we are solving for the equation, right? So now our value of a is 1. Now we take the value of b, which is negative 7. So our b is equals to negative 7. So we take it and we multiply it by half. And then we square, right? So this will give us negative 7 over 2 squared, like that. So we are done with this, we are done with that. So this we are going to edit and subtract it, right? So this will become x squared minus 7x plus negative 7 over 2 squared minus negative 7 over 2 squared, and then plus 6 is equals to 0. And this whole can be just simplified into x minus 7 over 2 squared. And that will give us negative 49 over 4 plus 6 is equals to 0. And you can add the 2. So now our x minus 7 over 2 squared, that gives us negative 25 over 4 being equals to 0. So this is an equation, so we can take this that side. So our x minus 7 over 2 squared will become 25 over 4. So we can do a square root both sides. So it means that now our x minus 7 over 2 will become plus or minus 5 over 2. So it means that on our face it will be x minus 7 over 2 is equals to 5 over 2, or x minus 7 over 2 will be equivalent to negative 5 over 2. So x here will become 5 over 2 plus 7 over 2, which will give us 6. And this one will be, x will be equals to negative 5 over 2 plus 7 over 2, which will give us 1. So x is equals to 6, or x is equals to 1, just like that. I hope you enjoyed this session with me. If you have enjoyed, please show me by subscribing, liking, and sharing the content on our channel, right? So we are going to get back with the quadratic formula and how to use the quadratic formula, and so on and so on, till we are done with this series of videos on algebra, equations and inequalities. See you on the next one.